And we're back for the box and the whisker, so let's get into it here. So, box and whisker, let's see how much you remember from this. We've got this data set that we're given 14, 19, 23, blah, 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 37, 38, and 44. For our box and whisker, we're going to draw something that has a box with the median in it and down to the minimum value and up to the maximum value. That's where we're heading towards. Inside each of these holds 25% of the data. So 25%, a quarter of the data, sits in this first part. This next one is a quarter of the data, the next one a quarter, and the next one the last quarter. Quartiles, remember we said quarters into fours. Okay, so we've got half, because 25 plus 25. So inside this box, if we looked at that, well, that bit there would be 50% of the data. So half the data is sitting in this box. And this is useful to see instead of just a crude mean or just a median, we can tell a little bit more about our data set. So let's look here. We've got how many sets here? How many data points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Cool. So we've got 14 data points. So where's our middle data point? Now, just quickly, let's have a look. Let's say you had 5 data points. So let's go 5 so you can see my 5 fingers. Well, if I showed you my median finger, which finger am I going to show you? Well, I'll show you this one, right? Can you see there it is in the middle. So we've got 1, 2, third one's in the middle, 4, 5. So with an odd number of fingers, then, or odd number of data points, we've got 1 in the middle. There it is. So out of 5 data points, the third one's the middle, no matter which way you count from. But let's say we've got 4 data points. Well, there's not 1 point in the middle, it's that gap between over there. So therefore, with an even number of data points, it's going to be those two, and we're going to get the average of those. So if, for example, this was 7 and 8, then midway in between would be 7.5. If it were 12 and 14, the median would be 13. Okay. That's if those values were that. Okay, so we've got an even number of data points. In this example, we've got 14 data points, we said. So we're going to have 2 data points in the middle. And with 4, we said it was 2 and 3. So with 14, makes sense, we're going to divide by 2. It's going to be 7, 7 and 8. So 1, 2, 3, 4, 5, 6, 7 and 8. Let's just check it. Well, we've got those 2. We've got 1, 2, 3, 4, 5, 6 to the left-hand side, and 1, 2, 3, 4, 5, 6 on the right-hand side. So those 2. So therefore, we know that our median is 31.5, because it's middle of those. You could go, okay, let's go 31 plus 32 over 2 gives us 31.5, but we can kind of see that. Okay, now we need to split our data set into 2, so we can find quartile 1 and quartile 3. Now, there are various methods to do this, and the method we're just going to do all the time is to go, let's break it up. There's the first half, and there's the second half over there. So now we've got, should have broken up into, well, if it was 14 to start with, should have been 7 and 7. Well, if there's 7, then the middle point must be this 4th point. And let's just see, when we highlight it, it's going to 1, 2, 3, 4. Does that make sense? 3 on the left, 3 on the right. So our Q1 is 28. And on the other side, 1, 2, 3, 4. Shouldn't matter which side we come from. 1, 2, 3, 4. So Q3 is 35. And finally, let's just throw in our min. That's easy. And our max is 44. Right. Now we just draw this in a box and whisker. Now the box and whisker does need to be to scale, because we're going to infer things from the picture, from the visualization. So we do need to make sure that it's to scale. I think, oh, that's where it says. Must be drawn to scale. So we're going to draw our very straight line. Oh, isn't there a straight line function here? So let's go like that. Okay, and it's going to go behind me, that's fine. And we have our points. So it must go 14 to 44. So I think it's probably easiest just to go, you know what, I'm just going to start at 15. And I'm going to go up in fives. Maybe it's going to be like 20, 25, 30, 35, 40, 45. Okay, 20, 25, 30, 35, 40, 45. And that's even. Obviously, just use that lovely thing called a ruler. And now we can put these points in. So I guess we should put 10 in. So let's extend that. So we've got 14. We've got 28. That's there. So that is going to go there. You've got the median here we said was 31.5. We said that the Q3 was 35. And our last point is 44. And this bit here we drew as a box. And these we drew as whiskers. Cool. So there's our box and whisker. It's useful either to put dotted lines to 14, or we can put these values above here so we know what they are. 35 and 44. Excellent. Obviously, use a ruler on your side rather than freehand drawing it like I have. It's just difficult to do on my side. Okay, cool. So there's our box and whisker. And what do we need to do? 25% in each one. We need to calculate the range. Okay, well, the range is just biggest minus smallest. So our range is just 44 minus 14 gives us 30, I think. Our interquartile range, well, interquartile range is IQR is just Q3 minus Q1. In other words, the bit in the box. So we've got equals 35 minus 28, give or take, is 7. Cool, so that's that. The semi-interquartile range, well, it's just that over 2. So the semi-interquartile range is 7 over 2. And identify if there are any outliers. Okay, so outliers, how we're going to describe our outliers is if we look at our interquartile range and we multiply it by 1.5. So if we take this box and we make it 1.5 times as big, are these points to the left of it? So this box here, let's say we drew it the same size. So 28 to 35, that's 7. So if we drew it down to 21 and another half, so it's 7, another 3.5. So down here to 17.5. So that's within 1.5. Let's write down what we're talking about. And clearly this is going to be an outlier according to this picture. So for our outliers, we're going 1.5 times the interquartile range. So that's 1.5 times 7 gives us 10.5. And Q1 minus 10.5. So Q1 was 28. So 28 minus 10.5 is 17.5. So anything left of 17.5 is an outlier. So clearly this is an outlier. So outlier number 1, let's put it above my head here, is outliers. I don't know if there'll be more. Well, we've got, not equals, that seems funny. We've got 14 so far. And if we took this box and we drew it, so we went 7 up, so up to 42. And another half, so another 3.5, because one box and 1.5 times. So we said this was 35 plus 7 is 42, 49.5. Clearly there's nothing outside. There's nothing like way extreme values. But we do need to show this in writing. So we've got 10.5, Q3 plus 10.5. Q3 was 35. 35 plus 10.5 is 46.5. In other words, that's what that value is. Therefore, there are no outliers on this side, so we've just got the one outlier. And I think that's it for now. Yeah, that's that. Hopefully, someone else falls somewhere along the line. Goodbye.